Today in class, this is on Monday, we built our swingers to do our experiments for the next unit. So our objective was to construct the materials to be used in an experiment, and there was no homework. Our swinger is based off of a pendulum, and a pendulum is a mass swinging back and forth on a string, also called in our classroom a swinger. Where have you seen a pendulum? These are real-life examples of where you've seen pendulums. Some examples are on a swing, like a swing set. The mass would be your body swinging back and forth. A grandfather clock, a pocket watch, a necklace, and a metronome. And I'll show you an example of that on the next page. The metronome is right here where my arrow is pointing. It's something that people who play musical instruments use. It ticks back and forth, back and forth. And that is the pendulum. It's just in a reverse direction. Have you ever ridden the Sky Coaster at Kennywood? That's also an example of a pendulum. The swing shot at Kennywood, those types of rides, as well as the Aero 360, are based on physics principles of pendulums. The next day in class, we started to use our swingers for an experiment. We conducted an experiment to find the number of swings a pendulum will make in 15 seconds. And we defined some terms: pendulum, cycle, and variable. No homework. First thing I asked the class to do is predict how many times do you think your swinger will swing in 15 seconds. And we set up an experiment to find out how. You can find that in the additional link to my page. You can see the swingers in action. Okay, so we did our time, 15 seconds. And when it was all over, we found out that the swingers would swing 12 times in 15 seconds. We talked about some different things you could change in your swinger system that might change the number of swings. For example, if I want more swings or less than 12 swings in that time period, what could I do? Some of the things we thought of were maybe changing the length of the string, adding or taking away some pennies, changing where we released the swinger at, using more force, and many other examples. All of those things are called variables. Variable is something you change in an experiment that might affect the outcome. So then we went into our word bank. We looked at the word pendulum again, which is a mass hanging from a fixed point that swings to and fro. We then talked about a cycle. A cycle is any motion or activity that repeats itself. The cycle in this lab would be the swinger coming back and forth, swaying back and forth. And finally, the word variable is anything that you change in an experiment that might affect the outcome. Then we went to our content section. We had one question to answer, and we just reviewed again what variables might affect the number of cycles the pendulum makes in 15 seconds. And those variables that we wrote down were mass, adding more pennies or taking them away, changing the length of the string, and then the starting position. And those are the ones we're testing in class today, on Wednesday. So today we're going to conduct a controlled experiment to find out the variables affect the number of cycles a pendulum will complete in a unit of time. We'll be working on a graph, and to finish that graph is the homework. We're going to start by looking at a standard pendulum system. A standard pendulum system is what we used in class. Okay? It's what we used in class. It is... Sorry about that. That's not what I want. Alright, sorry about that. What we did in class it is 38 centimeters. Alright, 38 centimeters long. We used one penny. We released it straight out. And we did that for 15 seconds. That is our standard. Everything else we will compare to that. In an experiment, an investigation designed to find out how variables affect the outcome. In a controlled experiment, which is what we do in class, it is where only one variable is changed, and then the outcome is compared to the standard. So we're starting by changing how many pennies we have. So our string is still 38 centimeters long. We're going to use 3 pennies now. We're going to keep releasing it straight out to the side, and we'll do it for 15 seconds. Our results, we ended up having the same number of swings, 12 swings. So we found out that the mass does not affect how a pendulum will swing. Alright, our next test, we change, not the length. We kept it to 1 penny, which was the standard, and we released it lower along the side, and for 15 seconds. And again, we found out it was the same, no difference. Okay, finally for our last test, we did different lengths of string. So, we didn't have the 38 centimeters anymore. Now we had different lengths, and they went anywhere from 13 to 200 centimeters long. 1 penny for each, release straight out for 15 seconds. And we did find out that there were more or fewer swings depending on the length of the string. Okay, this was the graph that we did in class. As people went around testing the different lengths, the numbers are here. We filled in how many swings it took. 13 centimeters would have a lot of swings, a lot more swings than 200. The longer it is, the less number of swings. The homework is to draw that up here on the graph. So all we did was make our swinger connect it to the graph. And we went into the word bank. And a controlled experiment is only one variable is changed in order to test its effects or assess its effects. And then we looked at standard. And a standard is the basic procedure used in a controlled experiment before changing any of the variables. Next we go to content. Which variables made no difference in the number of swings? That was the mass and the release position. Which variable did make a difference in the number of swings? And that was the length. And then finally, one last question, is there a relationship between the length of a pendulum and the number of swings it makes? The answer is yes. As the length of the pendulum increases, the number of swings decreases. As the length of the pendulum decreases, the number of swings increases.